The broadcast is now starting. All attendees are in listen-only mode.
All right, testing. Welcome everyone. Don't have anyone in the chat yet. If someone can let me know that you can hear me. I want to make sure that you guys can hear me before starting the webinar today. Sorry, we're starting a couple minutes late here. Just trying to, a little bit of technical difficulties. Just making sure I can get the screen showing here. Thank you, Brian. Let me know you guys can hear me. And if you guys can let me know, you can see the screen as well. And in the next couple minutes, we can get started here once we've got all of the attendees here, waiting for any other stragglers to join. Water too. All right, thanks, Brian. I appreciate let me know you guys can hear me, you guys can see my screen. And then I think we'll be starting here at 10 after to just waiting for any more attendees. Right now we've got 8 guys in here, and it did say there was going to be 20, so just waiting here for a couple more minutes to see if anyone else will be joining us today. We will be going over BobCAD version 35 that I'm in here, and we'll be going over the mill turn module. And my name's Eric. I am normally the demo technician, normally doing technical support tickets, helping you guys out with any questions, any problems you have in the software program. And also I do demonstrations of the software program for anyone interested in upgrading to any new module in the software program, and any prospects that don't yet have BobCAD and want to see a demonstration of what our software program entails. All right, open up the questions here. Hear you, see your screen. All right, cool. All right, it's 10 after now, so we will be starting here with a couple of CAD features that would help you with the mill turn program, being able to create a profile for turning and for your turned part, and then getting into the mill turn module here. So here in a blank page, we can draw. Normally we're drawing where the work offset is right here at the CAD origin. And with creating our profile, we're going in the -z direction here, which you can see the CAD coordinates is the -x direction. This is the standard X, Y, and Z coordinate plane. But if we want to be drawing in lathe coordinates, we can go here to the Home tab and go to Turning Mode. When I click that, you'll see instead of the X and Y coordinates, it will change to Z and X coordinates. So when I'm going in to create the outer diameter of the profile, for example, of the part, I start here at X3, Z0, and going backwards in the Z axis, and it will allow me to change that to -3, going out that way, maybe a taper outward in this direction, and I can change that that start point that I had created here, maybe -5 and x4, and then creating, just your basic drawing functions in here. If you want to do a chamfer or a fillet here, you can go here to your corners and changing the radius here of that fillet. Sketching outward, again in the z and x coordinates, starting at that z -5, x4, going outward, changing the coordinate point there if I want it to be z -7, x4, to go outward with that turn profile there. And if we import a solid model, like say for example I've got this here, and I'll blank everything out except for the solid model here. We've got our solid, and if we want to create the turned profile of this, the wireframe that I've got on this layer, I am going to create a new layer, go to create 2D, and we have this option called spun profile. I just select the solid model and keep it along the x-axis, so it'll be revolved around that axis there. Click OK, and then blank out that solid model. It gives us the turned profile, the wireframe of that solid model there. So very easy going in if you want to import a step file, SolidWorks part file, any other step file or IGES file, the generic file types for solid models. In other CAD software programs, bring in a solid model that way, then easily go to that spun profile, select the solid model to get the wireframe to select for your turned profile in the CAM portion of it, to turn down the stock, do a drilling operation here if you need to, those kinds of things. And like I said, normally we start here at the CAD origin. This part file is imported where it's out here in space. The back face of the solid model is here at the CAD origin. That's okay because we can go into the mill turn job and set up our machine setup accordingly for Z pointed out, X going up, and our work offset here at the front face of the stock if you're going to be using a probe, or touching your tools off here at the front face of the stock there. I'm going to look at the questions real quick one more time before I get into the mill turn portion of it. And then I'm not going to be looking at the questions for very much in the middle of this, but please ask type in any questions you have here. And if you, like I said, I may not get to them until the very end of the webinar, but I will answer any questions that you guys have pertaining to mill turn, or if any other questions arise too, just ask me there. I'll get to them by the end of the webinar here. So I'm going to start from the beginning with this part file with a mill turn job. We start by going to CAM up at the top, starting a new job. And we have our different job types here: milling, turning, mill turn, wire EDM. We'll select mill turn, and we'll select our machine. These are all of our generic BobCAD mill turn machines that are preloaded in the software program. And if you guys have like a Haas or any other type of machine that you're using, we do require a post request where we give you a worksheet to fill out, letting us know the axes of rotation, whether it's a 4 or 5 axis mill turn machine, how many turrets, how many spindles, and the limits to each axis as well, to make sure that there's not going to be any over travel, and the kinematics of the machine to make sure that there's not going to be any collisions with any of the tools on the turrets and anything else with the machine involved there. So with these different machines, BC stands for BobCAD, and 1T is one turret, 1S is one spindle. So this is our BobCAD 1 turret, 1 spindle machine, BobCAD 1 turret, 2 spindle machine. So if this has a sub spindle, we would select this. 1 turret, 2 spindle, where the tool is able to move in the y-axis as well, so X, Y, and Z movement. 2 turret, 2 spindle, 2 turret, 2 spindle, 5-axis. I'm going to start with the 1 turret, 1 spindle machine and define the stock here in our stock wizard next. We define our workpiece if we have the solid model, and then define the stock. So we're defining the stock here, whether it's rectangular, cylindrical, which is normally what we would be doing here for the for turning and for mill turn. And you can see it's not orientated correctly here. That's where we go down to the extrusion direction. So it's the cylinder is extruding out in Z. I'll change that to X, so it's orientated correctly. And to fit it around the part file, I just hit calculate stock again. It'll calculate that stock, making it the same diameter as the part that I have. I can change that diameter right here. If we need to turn down the stock a little bit more than the 6 inches, say if it's 6.5 inches, and I need to turn down the whole OD, I can set that up that way. I can change the height if we're doing a facing operation here. I can add a little bit more to the height. I can also add an offset, maybe add more to the start face, maybe an extra 100 thousandths. And you can see it update for the stock there if I need to face off 100 thousandths off of the stock to begin with. So that start face, end face, it'll add a little bit more to the backside there. Add a little bit more to the diameter. These are just incremental amounts added to the stock. These are absolute amounts added to the stock, you could say. So the height would be 5 inches. And it extrudes out in the negative X direction. I can change that origin point to make it start at 5, so that we've got it 5 overall. That's where the offset comes in, where it makes it very easy. We don't have to change the height and all of that right here and change the origin location. We can just add an extra amount here at the start face, for example. And then our last page is setting up our machine setup. Again, it starts here at the CAD origin. I want to change it at the front face here of the stock, since we're going to be coming in this way and turning down the stock, drilling the 3 holes here, profiling around the hex, those kinds of things. So I'm just going to click this bar for origin and click the origin point there. It creates a point right there at the front face of the stock. And I can change my X, Y, and Z directions accordingly. So we've got Z going outward. I'm going to click on a line parallel to the Z axis, reverse the direction so that Z positive is outward this way. And then we're coming in from Z0 here and negative Z into the stock, normally how it's programmed. And then I want to change my X direction going up as well. So I'm going to click this bar for X direction and click on the point going up. So now we've got it all orientated correctly for a mill turn job to be implemented there. I'm going to go to the existing mill turn job that I've got. It's the same orientation as what I just went over, creating the stock, creating the machine setup here at the front face of the stock, Z going outward, X pointed up, and then Y pointed towards us. And from the machine setup, it's very similar as programming for a milling job or for a turning job, where we right click on machine setup and we have our different features. grouped in different features for milling and for turning. So under the mill features, same as in the milling job, we have drilling and tapping, counterbore, facing, our 2.5 axis machining, all with the same available operations as in a milling job: profile rough, profile finish, pocket, facing, engraving, chamfer mill, corner rounding. And then we have our 3-axis milling operations in here as well. Doesn't necessarily pertain to mill turn, but they are in here if there's like an advanced rough, maybe like a pencil to follow along, a fillet, something like that there. If your machine has a y-axis, it could go in X, Y, and Z and follow along a curved surface that way. So once we have everything started up here, again with the stock, we're normally doing a cylindrical stock type. If you're basing it off of a casting and you need to do like some spring passes from a casting and focus on a certain area from a casting, you can select a solid model of the casting or select an STL file for the casting that you're using as well. So again, we begin by going to right-clicking on machine setup, going to turn features, and selecting lathe end face. I select my geometry by going to the wireframe that I've got and selecting this line here for the facing operation. Next, we set up the rapid plane, the region, either on the front face from the top going down or from the bottom going up. Set up a roughing operation, and we also have an option for a basic finish pass. If we want to add that in, we just add that operation in the operations list here. Posting, we can post out in separate moves and in CAN cycles. And then under submachine, we can select what turret we're using. The tool, depending on where the tool is, if the tool is mounted on the upper turret or lower turret. So that's what this stands for: upper turret main spindle, upper turret sub spindle, lower turret main spindle, lower turret sub spindle. So with this machine that I've got in here, I know I selected BobCAD 1 turret 1 spindle to begin with. With this mill turn job, pre-existing one that I've got, it's a BobCAD 2 turret 2 spindle machine. So it's got 2 turrets and a sub spindle as well. So back in the facing, rough, finish that I've got in this pre-existing facing feature, I'm doing separate moves on the upper turret and main spindle. Setting up our tool here for the roughing operation and setting up the tool insert, the tool holder, outputting an RPM or constant surface speed, spindle direction, tool number. And then when we go into the tool crib, this is a new feature here in mill turn versus turning, where it shows us our turret that we're using. These are all of the tools on the turret. We have 16 station numbers in this upper turret, and we can set up in the when setting up the machine, creating the machine, we set up how many station numbers are on each turret. It starts in the loose category here for your tool, and you just drag and drop it into a station number, and before you load it into a station number, you can also add an adapter. That's what these purple solids are here, are adapters for your milling tools and for your turning tools. And then you can add from tool library. If you're using a different tool here, go into the certain category, go into the lathe category, select a certain tool holder, those kinds of settings there. The tool that we're using here is this tool here in station number 1, and we can go to where it's highlighted here and change the axial shift of where it is located. So if we look at the coordinate system here, if I want to move it down a little bit further, I can move it down in negative x. So I'll say instead of -2, say -4, and then you'll see it update and move the tool down a little bit more than it was before. So we can shift it in X, Y, and Z so that we have the orientation. I mean, none of this is going to change the G code. It's just going to change in simulation the location of the tool so we can see and make sure that there won't be a collision with this and the stock with the spindle. And we can also change the mounting orientation here as well, if it's a left or a right hand tool or any other mounting orientation, if it's mounted on the side there or if it's straight up and down. Then our next page, turning on collision detection so that there's not going to be any collision with any part of the tool holder. Any non-cutting part of the stock will not gouge into the stock. It will avoid that area. And with this example here, if there was remaining stock right here, we would just use a different tool that would be able to fit into this area. But again, it won't gouge. It'll avoid that area, leaving a good amount of stock there to use a different tool to finish that off. Our next page, setting up a depth of cut for each pass. So we're going down 30 thousandths, or for the facing, we're going over 30 thousandths for each step over there. Finish allowance, we're leaving 10 thousandths in Z for the finish pass to clean up. Rapids, where the tool will wrap it from, where it will wrap it back after the operation to the next operation there. Our lead in and lead out page. Advanced feed rates. So if we're not able to set a rapid rate at the controller, we can change the rapid moves to feed moves so that we can set that rate. And we can set our feed rate for our lead in and our lead out. So right now it's going at a feed rate of 15 thousandths. And if I change that, I can change it as a percentage. So I could go 90% of that feed rate leading into the operation there. Next, we have MDI, and that stands for Manual Data Input. And these are various G&M codes that we can add in here. If we're programming for a tailstock, we could add that command in before the tool change. If we have a sub spindle, like we do with this machine, we can add in a part transfer. So if we're going after the operation to transfer the part from the main spindle to the sub spindle, we can load that in. We have all of the codes for just a generic part transfer or a generic cutoff and part transfer. So it'll do a cutoff operation and then transfer to the sub spindle. And with that, so after the tool change, it has all of these commands in here with that part transfer. It'll orient the main spindle. It'll enable the sub spindle, orient the sub spindle. It'll have a command to open the jaws, dwell for 1 second, move the sub spindle to a clearance plane in the Z-axis. All of those options: close jaws, dwell for 1 second, disable sub spindle, and then after operation, part transfer. You set where you want the sub spindle to go to the home location of the sub spindle there for your next operations on the other side of the part. So programming for a part transfer in that way, programming for a part catcher, raw text. So if you wanted to add that in, you can enter anything you want here. Delete that, and you can type in any comments, any type of G&M codes you want to add in there. You can add in with raw text as well. Yeah, other options in here. You need to set a work offset, C-axis engage. Yeah. And then our next page is setting up for the finish tool, for the finish operation, and setting up RPM, feed rate, setting up that tool. I believe we're using the same tool here in station number 1 for the finish pass for the facing operation. Turning on collision detection. You can do a continuous cut pattern, or we can alternate back and forth, horizontal and vertical, going along that way with that pass. You're going to see a lot of the same settings and parameters as you would in a turning job. So everything that you would see in a turning job for facing is going to be here with the cut pattern, collision detection, finish allowance, chip break option. So if we're wanting to, like mainly for the roughing, if we want to set a length of cut, we're only doing a 1/4 inch every time, and then retracting a certain distance. This is normally set to 50 thousandths. It'll move a 1/4 of an inch, move back so that it will it'll allow a chip break, so that there won't be so much of a buildup there with each pass. You won't build up so much of a bird's nest. You can set it as length of cut. You can set it as every 15 seconds to retract, and then come back in to make sure that the that chip break, or you could set it by length of chip as well. Next, just like in our turning job for facing, we've got our rapids, our lead in and lead out, advanced feed rates, and then MDI. So with that, we have, I'll show the solid again here. So I'll unblank the facing operation. This is the roughing. 3 passes for the roughing operation, 1 pass for the finish pass. And within each operation, under each feature, I can right click on the operation and backplot each operation. We can show the tool as shaded, as transparent, or as wireframe. And now we can show the visibility of the holder and the insert. So if I want to blank out the holder, just look at the tool insert and watch it come in, step through, and then see a step through for each pass there, and then go back to the rapid location and home location for a tool change. So that was the facing, the roughing, and the finish pass. Next we'll be turning down the stock on the OD, the outer diameter of it, roughing, and then a finish pass. Then we would start by right-clicking on Machine Setup, going to Turn Features, selecting Lathe Turning. We would select our geometry from the wireframe, and it would be from this line, all the way out to the outer diameter. I can hold Shift and click on this last line to chain select all of them to tell the software we're turning down that outer diameter here. If we're turning on the ID, I can select that. Or if we're turning on the front face or the back face, I can select those options as well. We've also got region 1 and region 2 for the outer diameter there, depending on how we're mounting the tool and the region that we're turning with the stock. We have a rough option, basic finish pass available operation, and also pattern repeat for multiple spring passes. Again, we can output in separate moves or can cycles. Select the sub machine. We're turning with the upper turret and main spindle again. setting up the tool and the tool holder, and we can go into the tool crib. This is highlighted under station number 10. So that's the highlighted one right down here. Looks like the only other turning tool that we're using, tool number 1, was this one highlighted, and then this tool that we're using, this 55-degree angle tool, is under station number 10 highlighted here. Then we'll click OK. Again, we've got our tool number, spindle direction, coolant type that we're using, flood, mist, air, oil, or off. Turning on collision detection. And then again, same kinds of patterns and parameters as we would in a turning operation under a turning job. So we're setting our depth of cut, finish allowance, and those same options as before: rapids, leads, advanced feed rates, and MDI. And so we have this one set up for the roughing of the outer diameter with the roughing and the finish pass, and I can backplot and just step through and see the finish pass here. Now we're only turning this amount because if we got in down a little any more, we would be cutting into the hex here. You can see the tool insert a little bit better from this isometric view with the background too being white. We'll step through, and then we'll close out of that. So that is unblanked now. We've got the facing right here and the roughing and finish pass of turning the outer diameter. Next, we've got set up the drilling operation for the 3 holes here. And so since we have 1 hole in the center, but the other 2 are off center for the rotary axis, we would be doing this under milling. So you right click on machine setup, go to mill features, and go to mill drill hole. Select our geometry, either the edges of the hole, we could select wireframe, or we could select the sleeves of the holes as well. We can pick the total depth here by picking bottom, picking that bottom edge there. It's not a through hole. And then we have this in one group together. We can break the whole group, so now they are all separated, and that way we can change the linking in between each of the holes under group retracts. So this is more for drilling with a milling job, where if we had a clamp in between 2 of the holes here, we can change the height of that retract for those 2 specific holes. And then, so we're looking at these 2 holes here, as in, let's see. No, we would be looking at these 2 holes. Would be these 2 here. So we would keep those in separate groups, and then I could hold Control or hold Shift and highlight both of these 2, which would be these 2 here in the same group. I would regroup those. So those 2 would have the rapid plane of 200 thousandths, and then in between these groups, which would be between this hole and linking from this hole to the other 2, I could change the group retracts to 1 inch, for example. So it would retract 1 inch between these 2 holes, and then 200 thousandths between these 2 holes. That would be the the usefulness of the group retracts here. Again, if you want to retract of just specific areas along your drilled holes here, and if you want to stay with the rapid plane where it's not necessary to retract that high, you have capability to be able to group the holes together here under the hole groups and set up the clearance plane for each of the retracts of each of the holes there. Then we have available operations for a center drill, a drill, chamfer drill, chamfer mill, reaming and boring operations. When it comes to drilling each of the holes, we have an optimized sorting order. We can pick the order, so if we need to manually select them here, we can pick one, and then the next, and then the next there. Grouping them manually, or picking the order manually. And then also I could set it in an X direction or a Y direction. If we have many holes, we want to sort them a certain way, we'll keep it at the optimized way there. We can set a work offset number, number 1 being G54, number 2 being G55, 56, and so on. If we're setting different work offsets for different tools, and if we're loading in different parts there. And posting mode, under drilling, we can set it up in auto Y-axis mode or in longhand code. If we're the next one is the profile, and in terms of posting out G-code, we can also output in polar interpolation. So essentially, I have a rough understanding of the polar interpolation is the certain coordinate that X will be at, and basically like the polar interpolation is basically like the diameter or the radius that the tool will be located at each location there. But anyways, yeah, you guys might know better about the polar interpolation coordinates, better explanation than I'm giving, but we do output in polar interpolation as well. So with drilling, we have those two options there. The polar interpolation is not applicable for drilling there. It's for milling profiles, pockets, things like that. So we're setting up the center drill, dwell time. I want to change the plunge feed rate, RPM, all those settings here. Go into the tool crib and set up the tool, which is going to be at station number 6 here, highlighted, and set the axial shift, set the mounting orientation there. And for each of the drilling operations now, we can do a single depth peck or fast peck down into the material. That's set up for all drilling operations now pertaining to center drill, reaming, boring operations. All of them now have these cycle types. And for each of the milling operations and each of the turning operations, they all have this MDI option for the different manual data input G&M codes here. Then we're setting up our drilling tool, setting up the cycle type, and our MDI page. Just like with the turning patterns and parameters, the milling patterns and parameters are going to be the same as you would see in a milling job. So when we're setting up the milling tool, we're setting up the compensation, the cut pattern, the parameters, all of those settings are going to be the same. So there's not going to be too much of a learning curve there. If you're familiar with a milling job, it's just going to be the same thing, just in the mill turn module. Same with turning, all the patterns and parameters. You're not going to have much of a learning curve here because they're all the same patterns and parameters that you would be used to in the turning job. So we'll start from the beginning here. We've got our top of feature and the total depth. We're going down to this bottom edge here, which is 1.25 inches. We have a profile rough and a profile finish set up. And again, we have all those operations that are in the mill to axis. We have options for tabs. It's really not going to pertain to mill turn. In a milling job, if we're cutting out different shapes, we can leave tabs along the corners or along the sides of a part if we don't have a vacuum table, so that we can leave tabs along areas of the part so it doesn't fall down onto the table. Then for posting, again, setting up our work offset number. We've got outputting in line moves or in arc moves. So in line moves, if we want to break it up into tiny line segments for the arcs, if the machine doesn't take arc moves as well as others. Then again, our posting modes, longhand code, y-axis mode, or polar interpolation, where again it'll have that X location of the tool, and you can see it in the G code as well. We can set it up for polar interpolation there. Setting up the tool for the profile rough. Again, the tool is going to be facing towards the front face of the stock for this tool, for this operation. And then again, our cut patterns, just like we would in a milling job, we have a standard profile cut, contour ramping, helical ramp down into the material, or side roughing, where we can set a certain step over and number of passes. So we can do multiple passes until we get to the last pass there for the profile. Set up our compensation on the left or the right side of our path, giving us our climb mill or conventional milling options. With this outer profile cut, if we're compensating on the right, it will go counterclockwise. Go to the left, it will go clockwise with that compensation. Then we have options for spring passes as well now. So we can set, just like as we did with the turning, we can set a number of passes for multiple spring passes with that finish setting there. Then we're setting an allowance. We're leaving 10 thousandths on the sides for the finish pass to clean up. The bottom allowance option, single step or multiple steps down. We're going to be going a 1/4 inch depth of cut each time, with a total of 5 number of cuts there to get it down to 1.25 inches for this roughing profile. Then we can set whether we want to plunge or ramp continually down into the material, entering into the stock. And we also have a lead in and lead out option. We have our vertical, parallel, right angle, circular options. A couple new lead in and lead out options in version 35, point and point blend. So I can select a specific point that I want it to start at, and then lead from the center, working its way in, and pick the point that I want it to start at exactly. And also point blend, so it'll start at that certain point I wanted to select, and then arc in. Then we have corner types, going around the corners. We could also break up the corners with a loop radius, different options like that. If we don't want to stall in the corners for too long, it'll work its way out and come back in after staying out here for a certain amount of time in the corners there. Machine sequence, again, setting up the sorting order closest. No sorting where I can manually sort the certain profiles I'm cutting. I'm just doing one, so it's not necessarily applicable for this. But if we're doing multiple profiles, set it in an X or a Y direction. Just go to closest. Advanced feed rates for milling. We can convert rapid moves to feed moves again and set a feed rate for our lead in and our lead out. We also have a corner slowdown option where we have an arc look ahead option. So we have arc look ahead count, so number of steps before setting up the arc, number of divisions for that corner, and then also setting the distance from the corner that we could change the feed rate percentage as. Next, we have our MDI page and same kinds of manual direct input G&M codes for milling, just as we did with turning. Setting up the finish tool. This again is going to be facing the front face of the stock, to be doing a profile around that way. Compensation options, 0 allowance, as this will be for the finish pass. And then our lead in, lead out, corner types, machine sequence, advanced feed rates, all of those same settings as before there. Did I change the oh yeah, I changed the posting there for polar interpolation, so we can see that in the G-code also. So now everything has been set up where we have, and maybe I'll just turn everything off so we can see what we currently have in the simulation and take a look at that to start off with. Good stopping point to see if anyone has any questions while that's loading in. Brian, any plans to allow selecting the solid for turning ops? Yes, that's a good question. So currently we have that in SolidWorks, where you can select the surfaces for turning operations, and that is in the works now for selecting surfaces to be able to turn down the stock. I would say the difficulty that we are running into with development, I would say, would be the selecting surfaces, just as we saw here with the hex. If we select the surfaces, it might go down to that very bottom level, which we don't want. We're just kind of getting everything situated to be able to select the surfaces. The software can understand the spun profile, as it were, with the 2D wireframe, to be able to turn down the stock with surfaces. That's currently in the works. It's a feature request with our development department, and yeah, it will be implemented soon, that's for sure. Thanks, Brian. And then Roberto, how will you program a mill hub to create gears? So I'm not sure if you're pertaining to or referencing like maybe doing like a gear like this here, being able to set up in our CAD version, which is very helpful, our gear generator. You can set up the number of teeth, the outside diameter, pitch diameter, root diameter, radius for the root fillet, those kinds of options there, and then be able to do a profile for this. But you may be talking about something else with the gear hub. But yeah, once we have the profile of it, then just as we did with the profile of this, we would just set it up in a mill turn job and be able to select that geometry for a profile operation, just as we did here, multiple passes, finish pass. I don't know if that's what you're interested in for a gear, or if there's something else for a gear hub. Let me know if you've got any other questions with that one also. Now we can look at, oops, there we go. No, it's not. Let's see. Something with the tool it was saying. One other thing that I was going to point out too, with version 35, now we have the simulation that will open in a separate window, which can be very helpful. I'm saying something about a certain tool I need to change, adjust, but this is very helpful where you can go into the go on a different window, move it to a different monitor now, and so that you can look at the part file and you can work in the part file, do your CAD geometry, modify any features, and then I believe all you would have to do is restart and then run the simulation again after you've made any adjustments here in the CAM tree or made any adjustments here in the CAD, reselect the geometry, recompute, and then you can go back to your simulation here and run it from there. So instead of having to, what we had, if you guys have version 35, you can find that under File, then I believe it's under Settings. So File, Settings, and then I found it here before, and then under CAM. So yeah, it's File, Settings, CAM, and then under Simulation, Simulation window if you want it in a separate window, or the embedded window as it normally is in the older versions. You have it embedded in here. But now we can do it in a separate window, so you can put it on a different on a separate monitor and be able to run it from there. So very helpful. I may have made some adjustments with the tools, so let me reopen the part file here. Shouldn't be getting any kind of error message. Not sure what's going on there. Return. Yeah, so and just real quick, going back to your question there, Roberto, yes, that's it. I'll be using a mill hub using live tooling. So yeah, going back to that drawing that I just quickly created there of a gear, what I would do is just go to, you could easily just go to CAM, new job, mill turn, set up your machine, set up the stock in the cylinder here, and then so setting up the diameter that you're using, the height, things like that, and then the next page, setting up your Z and X coordinates. I've got it drawn up here where it's already set up Z and X there on the front face of the stock. Going to mill features, go to mill 2 axis, select that gear, total depth, I believe the stock is just 1 inch there. Setting up a profile rough, profile finish, and then same as we just went in with the mill turn 1 part file here, going into the profile rough, profile finish, setting up my roughing tool there. So as you can see, it starts in the loose category. I just drag it into a station number, set up the mounting orientation. It's going to be facing the front face of the stock here. And then yeah, going from there, setting up the system compensation, side allowance, all of those parameters there. Setting up the finish tool, going into the tool crib, and then moving it from the loose category. I'm using a different tool for the finish operation here. Make it right alongside there of the turret, the opposite side. Set up the compensation, and set up all of those patterns and parameters. Now if we look at it here, it's cutting on the inside of the gear. To go, we highlight default change start point, it's going counterclockwise and compensating on the left. If I wanted to compensate on the left and go clockwise on the outside, I just right click on default change start point, reverse the direction, you'll see the arrow going the opposite way, and then recompute the tool path. That's as far as that half-inch tool will be able to fit into. Maybe I'll change this, change the finish tool to make it a 1/4 inch tool and look at simulation that way. 1/4 inch, and compute that. And with the another thing with simulation is with Millturn, you automatically get the Machine Simulation Pro. So the anything else really, you'll have in milling or with turning, you'll have the Machine Simulation Standard, which will just have the stock and the tools. In Machine Simulation Pro, it shows the stock here inside of the spindle, which I can change, show you how to change here. But at least you'll be able to see the stock, the turrets that you're using, spindles, and the tools on the turret as well. So it's a very useful simulation that we have. I would say very robust simulation for being able to look at the machine and all the kinematics of the machine. And we go here to move the stock out of the spindle. We would right click on Machine Setup 1, go to Edit, and down here at the bottom we have Work Offset in X, Y, and Z. So I'm going to offset this, I'll say 1.5 inches, so that it will be more than enough outward of the spindle. It's where the work offset is going to be located in the spindle here. And still got the jaws. I think those will go away once we start simulation. No, okay, it's locked in that way. Gotcha. So I may want to move the stock outward so that the jaws aren't going to be having a collision, or the tool's not going to have a collision with the jaws here. But with that work offset in X, Y, and Z in the machine setup, it does not change anything in the G code. It just changes the simulation here. It changes the stock location of the simulation, where XYZ 0 location right here is not at 0 at the top of the spindle here. I can move it outward in Z so that it doesn't have any collision. And then this red also is showing a collision. If we look at under report here at the bottom, we have collision between stock and tool, and we can see the reason for it is the tool, the cutting part of the tool here in yellow is not long enough for the stock here. It's only 3/4 inch, I believe, and so all I would have to do to fix that is go to the tool page and change the flute length. I believe I'd have to go into this one and change the flute length of it here. But that's how you would change it to make sure that there won't be a collision there. Change the flute length, change it to 2 inches instead. Oh, and then I'll change the stock orientation as well. So again, just right click on Machine Setup 1, Edit, and I'll change this to 3 inches, and then view that in simulation. And then we'll start it. The jaws don't lock on because it's outward of the stock is outside of the jaw location. So a little bit of manipulating with that work offset. I would want to change that work offset XYZ, maybe move it back so that it'd be 2.5 inches instead of 3. But at least now there's not any errors there. Tool's large enough. The tool flute length is long enough to be able to cut into the gear hub there. And actually a nice segue into this, where if we're cutting from the side, or cutting the side of it with a profile cut like this, that's how we would do it. And next, we'll be looking back at mill turn 1 to see how the tool will be, how we can program for the tool to cut into the onto the side of the, or into the side of the stock, you could say. That's going to be next here. Then, yeah, no problem, Roberto. Would be 104 teeth. Yeah, you can just go into that gear generator and set up the number of teeth there instead of 1604 and change all the parameters that you need for a gear. And also, so we'll go back into mill turn 1. Sorry, kind of juggling around with the questions here. But one other question you guys had, Kyle, can the volume of a part be calculated, and if so, how? Yes, and it's very easy to. Once we've got a solid model, we can go to evaluate and measure 1. We'll check this box, pick solid, and pick the solid here. On the side here where it's under this measure entity box, it says the area and the volume. So surface area 120 square inches, volume 41 inches cubed. If we want to measure for inches, if we want to measure for millimeters, just go down here to the bottom right with this drop down, change it from inch to millimeter, for example, and then go back into evaluate, measure 1, make sure the checkbox for pick solid is turned on, and just click on the solid. And now we've got everything in here, surface area and volume in millimeters instead of inches. All right, and now we should be able to look at simulation for this. I think one of these are, or actually all of it should be working now since I just reopened it. Just reopened the part file, so everything should be working just fine. Awesome. So yeah, you can see that the stock is right here exactly for the spindle here. And I'm just curious as to what the work offset XYZ is. 6 inches. The stock is 4.6 and 4.625, and the work offset is 6 inches. So we just have just enough to where the spindle will hold on to it, and enough so that there won't be any collisions with the turning and milling operations here. So we'll simulate what we've got done so far in this part file that we've went over already, the facing, turning on the outer diameter, drilling, and profile for the hex. I've got all of these turned on with this post yes no option. If I want to turn on or turn off, I can just click on this button. It'll turn it off with this X mark. If I click it again, it'll turn it on. And it will also, so if I have only these 4 turned on, it will only post the G code for these 4 features and won't post the rest of what I've got programmed. If I don't want to post the G code for the profile hex, for example, I just turn that off, and when I post, it won't post that feature as well. All right, so we've got our BobCAD 2 turret, 2 spindle machine, the stock, and the tools for our facing operation first. Next, the turning operation for the outer diameter. Looks like it's got a collision between the that roughing operation for that first pass there getting into the spindle. I want to change that before we post it. But here's the roughing of the outer diameter. The finish pass. Might hit the spindle again here. Yeah, we'll want to turn off that so that it or create the toolpath so it doesn't go all the way across the stock. But anyways, I'll turn off the toolpath here. Under visibility, turn off the toolpath so we can see the drilling operation, and then the profile cut. And now this is the BobCAD 2 turret, 2 spindle machine. It does not have a y-axis. So the tool is not moving around the hex to create the profile. Instead, the tool is moving back and forth in the x-axis of the tool, and the part is rotating around the spindle in the c-axis so that we can achieve that profile cut. If your machine has a y-axis and you use that machine and you have enough travel in y for the tool to move around instead of the part rotating around, you can program for that as well. All right, so we've got everything programmed for the tools coming, the milling tools coming in, facing the front face of the stock here. Now we have to program for the profile, the pocket and profile finish pass here, the drilling operations, and milling the flats and the drilled holes on the sides of the stock here. So the tool will be oriented a different way than it is right now, where the tool is facing the front face of the stock. So I'll close out a backplot first and start by programming with that. We have to create an index system along each of those surfaces. And I start in doing that by right-clicking on Machine Setup, going to Additional Functions, and selecting Add Index. I select this surface so that this arrow will be our z-axis coordinate, instead of the z-axis coordinate being on the front face of this stock that we have for this machine setup. This will be our new z-axis for our machine setup when programming for this pocket. So I can pick a surface under this index system selection. I can also pick a UCS. So if I created a user coordinate system down under here, instead of, you can see top, front, or side UCS. If I created a UCS at this surface specifically, I can pick that UCS under the drop downs for that surface or for that location. But since I've got the surface, I'm just going to pick the surface and use that as my new z-axis. Instead of the machine setup, we've got the index system for the z-axis pointed towards the side of the stock instead of the front face of the stock. So I'll delete that one I just created since I've got it under here, index system, side pocket. That's what I did there. And then from there, I just right click on the index system, and then I'll be programming from that from that setting there. Whether I'm doing any milling operations here, so drilling, tapping, counterbore, it'll be under 2-axis. Select geometry. I can just select, what I would probably do is just right click on one of these edges down at the bottom, and I think I can just click constant Z. Yep, it'll select all of the edges that are tangent to that surface edge in a constant Z location. Or if I delete all of that selection there, I can right click and select loop selection. It'll give me some highlighted edges that I can click on. If I want to click on one of these 3 edges, it'll select that loop selection from the surface edge I've selected. Anything touching that surface edge, it'll select that loop selection, or loop selection and then select one of those edges around here that can't see very well, but they are all highlighted. I click on one of those highlighted edges around it, and then it will give me the loop selection around that as well. So those are the two options under loop selection and constant Z. Now this is not in a constant Z because you can see the curved surface, so I don't expect it to select all of them. It just selects that one. But I can select all of the edges on the top surface edges by loop selection, and then clicking one of those again here, one of them going around that loop versus loop selection, and I've got the other loop selection here as well, but that doesn't give me anything for toolpath. So I right click on surface on a surface edge, loop selection, select one of these edges around here for that. Pick top. So the top of the pocket will be up here at the top here, and then the total depth will be down here at the bottom surface edge. Next we have, again, I can pick the top of feature, total depth, which I already did. I would be doing a pocket with a profile finish. If I don't want to do a profile finish for whatever reason, I can delete that operation. We've just got the pocket here. Then we've got tabs, posting, multi-axis post, but you don't have to deal with any of that. All of that is set up within the post processor and the machine build. This is all grayed out, set up by default. Don't have to change anything there. Then we set up our tool. Go into the tool crib, select our certain tool, what station number, and the mounting orientation. So this is not the right mounting orientation for it. It would be more like this here. And that would already be set up in the pocket feature I've already got set up. So I go right to that tool page, go to the tool crib, and yep, that is my highlighted tool that I'm using. It's already mounted to the side of the turret. I'm going to be facing the side of the stock there. This mounting orientation would be towards the front face of the stock. I'll be using this mounting orientation, set whatever axial shift I need, but it looks like it's orientated pretty well along with the adapter there. So our next page, different cut patterns for the pocket, just as you would be familiar with in the pocket feature for a milling job. You have the standard pocket and you have the advanced pocket, which can be helpful if you have an open pocket. You can now select the surfaces. So if you had, like, say for example, doing a pocket routine on an open surface like this, you select the geometry, you've got this detect open edges option now. So if you select a surface, it will detect all of the open edges, which would be these three, do an open pocket and open pocket routine instead for you. So in the past, you would have had to create the wireframe, create those wireframe lines as dashed lines instead of solid lines. You don't have to go through all of that CAD manipulation. You can now go to the geometry, select, and detect open edges for an open pocket routine. So yeah, kind of a long-winded explanation of the advanced pockets here, where you can do an open pocket. You also have, instead of the standard pocket, advanced pocket also offers the high-speed machining options with morph, spiral, and adaptive roughing, where the tool will start at the center, continually spiral its way out, keeping constant tool engagement the whole time with these operations. These are our two high-speed machining options there. I'm just going to stay with the standard pocket for this one and leave a side allowance of 10 thousandths of an inch on the side walls for the finish pass to clean up. Again, we'll be doing multiple steps at 150 thousandths for each step down, giving us 3 total number of cuts there. We can plunge, ramp, or spiral into the material entering into the stock. We can also do a single depth down peck or fast peck down into the material with the end mill with that plunge option. Sorting order, we've got multiple pockets, closest order, no sorting where I can sort the different pockets myself or set it in a certain direction. Linking for each step over, we've just got a direct link for each step over there. Converting rapid moves to feed moves and setting a corner slowdown option there. Then our MDI commands, just as we did with the turning operations. Setting up our milling tool for the profile finish pass. If we go into the tool crib, we'll see that that tool is also located mounted on the side of the turret so that it is facing the side of the stock. Next, we have our system compensation. We could also compensate under machine compensation for G41 or G42 to output for tool wear and other parameters for compensation at the controller. We're not setting any allowance for the finish pass, and we're only doing one single profile pass there at the full depth. Plunge down and a blended lead in, so it'll start with a linear move and then a tangent move into the profile pass. Corner type options, machine sequence, advanced feed rates, all those same settings as before. And there we have the feature for the side pocket. We will right click on the pocket and backplot just to see it kind of play through here. Start from the center and work its way out. That is the pocket out option, doing multiple passes and multiple depths of cut inside the pocket there. Then the profile finish, starting with a lead in and then tangent to that profile pass and then that lead out there. So that is how you program for tools mounted on the side of the turret and milling any areas on the side of the stock. Next will be milling on this side of the stock here. And I think it's the same angle direction, but we were just going to be safe, create an index on that surface. So I just pick a surface there. That will be my index for that operation. And from that index system, I did mill to axis. What we did was just select this surface edge here in this mill flats option. We did a profile rough, and we just did a side roughing routine where we set that it was 3/4 of an inch remaining of stock, and we're going to be doing 3 passes to achieve that with a step over of 1/4 of an inch each pass. No side allowance, single step down. We're not doing a certain depth of cut. We're going to the full depth. Set our lead in and lead out. We're doing a parallel lead in and lead out, starting a 1/4 of an inch before and after. Corner types, machine sequence, advanced feed rates, and MDI, just like before there. And then we're also drilling the holes as well. So selecting that geometry and then setting the drill. Instead of having to index on each of these surfaces for the toolpath, we can right click on each feature and go to add toolpath pattern. That's what we did here. And we selected rotate. So we're going to rotate the toolpath around to create copies. We're creating 5 additional copies of this toolpath, 1, 2, 3, 4, 5, and rotating the toolpath 60 degrees each time for each copy there. And setting the rotation axis, the center line of the stock as our rotation axis for the toolpath there. So that makes things a lot more convenient than having to index on each surface and I mean, we're just using the same tools, the same cut pattern and parameters, so we don't need to change anything. We just use that toolpath pattern to make 5 additional copies, 60 degrees each time, to go a full 360 from the original toolpath that we've got. So that's it with indexing and programming for the flats and the holes to be drilled down at the bottom there. I'll post that one now. And the last one that we have is the holes on the top and bottom here that we're going to be looking at. And we just do that again by creating an index system, selecting this surface as our index. Then from the index, right-clicking on it and going to mill drill hole for these, selecting the geometry of the 2 sleeves of the hole, or you can select the surface edges if you want. The nice part about selecting the sleeves of the holes is it does pick up the depth. You don't have to pick bottom, go inside the hole and select it. They'll pick up the depth for you. You got center drill, chamfer drill, ream, boring operations. We're doing a center drill and a drill operations there and under this feature. Optimize sorting order, work offset number, using the upper turret and the main spindle, center drill, single depth down, MDI, drill, single depth down, and then our MDI page there. And then just like with the toolpath pattern on the back side of the part, we don't have to index on the top here. It can save us some time by right-clicking on the feature, going to toolpath pattern, and then I rotated the toolpath 180 degrees and just made 1 copy for the top of the part there. So from there, I will turn on everything under that index system as well and simulate. See if you guys have any more questions while that's loading in. Let's see. Roberto, good question about tech support, the cost, all of that. So with technical support, it is a yearly plan. Not going to get too much into it with the webinar here, and also I'm not one of the guys with pricing information, but I will have someone reach out to you, Roberto, regarding pricing information, things like that with mill turn. And if anyone else has any questions about pricing with this, you can message in the questions box, or you can email us at support@bobcad.com. And our tech support number also, that's our email address for tech support, support@bobcad.com. Our phone number for tech support is 727-489-0003. That's 727-489-0003. If you guys have any questions with the mill turn module that we went over today, or anything else in the software program, if you guys have any questions, any concerns, anything not going right for you, and you're on a support plan, let us know. Let us know any concerns that you've got. And you can also call that number if you don't have tech support. We can still get you in the right direction to get you current on a support plan. So here's the profile that we already saw in simulation before, and then we'll be getting into the indexing portion of it. So that's all done with the profile. And for some reason, this last one is crashing into it. What is this last one? So this is the profile. This is the pocket hex. Side pocket. Let's see what's going on there. We got that. I might have to just like update geometry and recompute it. Or even, I mean, because I've been modifying this a lot. Let me reopen the part file again and see if that works. If not, see what's going on with that depth that I'm using, things like that. Let's see. All right, and then James asking, can you please show how to set up for subspindle machining? Milling and turning don't need to see part transfer things. To set up for subspindle machine. Yeah. Okay. Yep, I will. I'll show you guys that next. How to set up a new machine setup for the subspindle, and how to start programming for that next. Once I get this working here. So we've got the turning. And I'll hide the toolpath there so we can see everything. So turning, drilling, and then milling around the profile of the hex. And then we'll be, hopefully the geometry is updated for that side pocket there. Should be working. Can't remember when I created this part file. It's probably like back in like 32 or version 33, so hope everything transferred over well to 35. Has been working in 34. Might have to reselect that tool for whatever reason. It's creating. Yeah, no, it's doing the same thing there. Got to recreate that or reselect that tool there for the side pocket. Looks like. So we'll go into the tool crib, make sure everything's looking good here. And this is under lower turret main spindle. Yep. Everything looks good. Try it one more time. And then if not, we'll just skip to the next section, looking at setting up for a sub spindle here. I can just skip operations as well. Just gonna pause it and then skip to next operation, next operation. So we've got the hex. Let's see what's going on with the hex tool here. Okay, profile finish for the hex. Oh, I see the tool here. I think that's what is making the problem there. Yep, okay. Let's make sure the index, index is correct. And for some reason, the tool is like mounted this way in simulation. Let's try to mount it the opposite way there. And same with this tool. It's for some reason mounted like that. Let's try to mount it the opposite way. Try this one last time. Still got that same tool looking like, yeah, it's still the same tool looking like that. I'm not sure what's going on with the, let me turn that off and see if we can look at the flats at least. Skip the pocket there. Can also go to the move list here. And if I double click on one of them, say we'll double click on the drill so we can skip all the way to that portion of it. And then run it from there. That's that certain tool that's not working well for us. Let's see if the drill will work for us, that drill on the top and bottom. Yeah, it's still not getting the right depth there for some reason. Yeah, it's an older part file. For some reason, the depth isn't working out correctly for us. Let's skip to the programming on the sub spindle. So say if I wanted to drill the 3 holes on the other side of it, programming for it, it's similar to creating an index system like we've got here. We right click on machine setup 1, go to additional functions, and go to add insert setup. So under machine setup 1, we have it where z-axis is pointed out this way, x is going up. We still want x going up, but z going the opposite direction. So we right click on machine setup 2 and edit. Set the z direction parallel to this axis. It's going the correct direction for us, so we don't have to reverse the direction. And then I highlight x direction and then click on this point for it going up. Now Z changed on us again, so I'll go back, click on that line, and now I've got it correct. So we want to make sure machine setup 2, basically the opposite of machine setup 1. Z-axis going outward, but I'm sorry, yeah, Z-axis pointed outward, X-axis going up. So we still want X-axis pointed up, but Z in the opposite direction. And from there, mill features, drill hole, select geometry, so I'll select the 3 sleeves of the holes here. And these are through holes, so I'll leave that checked. Setting up for a drill, center drill and a drill. Optimize sorting order. All of this is fine. Use the center drill and go to the tool crib and set up that tool because we don't have anything set up in that regard yet. And so we would be using, I'm not gonna, oh wait, let's see. Maybe that one, no, sorry. So, okay, so we have to go to the tool library, select the certain tool we're using, and I'm just gonna use one that I know we're not using at the moment. This is 1/2 inch. So I'll just do this 0 center drill, and it is again, not pointed the way I want it to. I'm going to put it in a different station number. Put it under station number 15. And I'll have station number 16 for that other drill. The mounting orientation is going to be the opposite of this direction, so it will be number 3 instead of number 1. I would want it with an axial shift in the positive Z direction, just so we can see it very well in simulation. I'm not going to mess around with the adapter. I'm just going to move this tool outward in Z. We'll say 4 inches. Should be, yeah, that should be plenty. And then click OK. And then it's just going to be a single depth MDI page, and the drill tool will be in the tool crib under the loose category. I have to drag and drop it into station number 16. Change the mounting orientation again from 1 to 3. Move it in an axial shift. I'll move this also 4 inches. But we've got the 2 tools out here in space. Just haven't created an adapter for either of those yet. We would just go in first. Before we did that, we would right click on station number and then add adapter, select the right ones that we're using in here. I believe it's under VDI. It would be under one of, there should be a drill adapter in here. Base milling. Yeah, so I'll just leave those. So that's what you would do first, was select an adapter if you want to see it in simulation, and then be able to mount your tools with it, but you can leave it in the station number there like we have it here. Then setting the single depth and MDI will compute for those. There's the toolpath for it. I'm going to turn off these 3 index systems for the time being to look at. We can backplot it first. So right click on each operation and backplot. So this is the center drill for each of them. And then the drill under backplot, that 3/4 inch drill. We can look at a simulation. I'm not going to look at the machine because we don't have the the part transfer for it, but that's how you would program. You would first do under the last operation under machine setup. You would go to that MDI page. You would go to part transfer and load in the part transfer MDI, manual direct input. You have to make sure that the certain part transfer is the pickup location should be 0 at the front face of the stock. I believe it has to be a little bit more with the depth so that you can transfer over and set it that way. And then also sending the subspindle to the certain location that it needs to go to for the operations. Oh yeah, one other would be upper turret. It'd be upper turret, but it would be subspindle. And then under posting, it would be upper turret subspindle. So that might work for the simulation to see that. But yeah, that's how you would go about just programming for the subspindle there. And then setting up the tools in the turret and programming for each one of those. You can backplot each one and be able to post for them afterward. Let's see if you guys, and yeah, if you guys have any other questions, please let me know in here. So yeah, James, you were asking about milling and turning. That's how you would do it in milling, and in turning, same. You could do it in the same machine setup here. Machine setup 2. Right click, turn features. Say turning on the outer diameter here. We are selecting the wireframe, so we go back to the layers, hide the solid, select the line that we're turning down the stock for, outer diameter, and then the only difference would be, again, going to the tool crib and changing that mounting orientation. So we would go in, I'm going to go to add from tool library. We don't have one in there yet. We'll say a roughing tool, select a certain tool here, and then when we bring it in, yeah, that's fine. We can use it as station number 10 for this one. Mounting orientation, instead of 1, it'll be 2. And yeah, it wouldn't be the, I don't think it'd be this, well, I guess it would be this certain adapter, but again, we would have to do this axial shift in Z. So we would move it over, let's say 2 inches. No, it's going to be much more than that. Something more like 6 or 8 inches. So 6-inch axial shift to have it on the right side of the adapter to be able to see that in simulation and program for it the specific way there. And other than that, in posting, just want to make sure it's under upper turret subspindle there. And so from that, we can see the toolpath is right here, and we can backplot it. And that's how you would be able to program on the subspindle. Yeah, so it's just getting that small area there. The only remaining area of the stock there was what that was cutting there. But yeah, so that's how you'd be programming for the milling features and for turning features on a subspindle. Just using a different machine setup than you would for the main spindle. And also under the machine setup 2, it would be using the subspindle option. So instead of left spindle, be right spindle. So that you have upper turret, subspindle, and programming for it. Yeah, let me see if you guys have any other questions here. We got 10 minutes remaining. Subspindle is, I'm going to read what you got here, James. When subspindle is set up, posted turning toolpath has inverted arcs. Yeah, I think this would, you're right, James. I think this would be a better question for support. This sounds like a posting question, something in terms of the arcs not outputting the way you're expecting, outputting inverted arcs in the program. So yeah, I would say if you could send us a sample program that is what it's doing to you, and also send us a sample program of how it's supposed to look, we can get our post-processor department in on that to see what's going on, if it's with simulation also, and with posting the G code to make sure everything lines up correctly for you, like you're saying. Yeah, so other than that, did you guys have any other questions overall? If not, I'm going to be closing out of the webinar here in the next couple minutes. Just wanted to say thank you to everyone that joined today and looked in on the webinar today, going over the mill turn program. If you guys have any questions with technical support, again, you can email us to support@bobcad.com. You can also call us at our support line, area code 727-489-0003. And also any other questions that you have with support or anything else with the Milturn module we went over here today, you can ask us at that number or email address. And again, yeah, thank you, Brian, for the questions there. And thank you, everyone, for joining in. And hope you guys have a great rest of your day. Thank you very much.